Hello everyone. Today I want to show how I made my architecture shader. So this is a pretty powerful shader that I use it for most of the environment here. And it contains a few features such as blend, overlay, and scaling. So today I'm not gonna talk about the scaling part. I'll leave that for another video, but I want to show the overlay and the blend. And here's a demonstration of how this shader looks. And by the way, this content is 100% usable on Unreal. And actually the code for the actual height transition I took from Unreal. Unreal already comes with this node, HeightLERP. So I just opened that node and I rebuilt it in Unity using the same nodes. So this knowledge is very transferable. Both engines have the same workflow. And I'm just recovering from a cold, so never mind if my voice is a little off today. So okay. Let me show the features. So one cool thing when making this kind of catch-all kind of shaders is keeping things organized. So I have layer 1, 2, blend, overlay, and UV scaling, right? So very easy to toggle what I need. Like if you don't do this, it gets very complicated to use your shaders. So always think about usability when creating this kind of stuff. And another reason that I have it separated is you're gonna notice that every section except the layer 1 has a toggle. So I do this so I can have the shader be more optimized, right? Because if I don't need a second layer, I can just disable and that cost will be gone, right? If this is always active, even if you're not using, that's a lot of wasted performance. So that's how I like to see this. And the same for the overlay. So if I can toggle on and off and choose to have or not to have. So this is a very versatile shader. And so some of the base features I have here, let me go to this one here. So for each layer I only have 2 adjustments, which is the color tint, and this is just normal like color tint, and then I have a color map, normal map, and ORM, which stands for AO, roughness, and metallic. I used to use MRAO in the past, metallic, roughness, AO. But I think it's kind of a standard now to use ORM. So if you can, just use ORM. A lot of the assets from Marketplace, they come with this standard. And the other settings, the roughness multiply. So I can make things like more rough or less rough. So I'm gonna show how to do all of this. And then the layer 2 is the same settings. I also have a tint and a roughness multiply. And now we get to the blend section. And the blend section will take a mask. And in this case for the plaster, here's how my mask looks like. It's just a bunch of clouds and noise and shapes. I go in depth on how to create this kind of masks in the Environment Art Mastery. But for the sake of this tutorial, I'm just gonna say that I made this in Photoshop with a few brushes. You know, it took a lot of experimentation. So if you look at this and you're like, oh, I don't understand what's happening, like I don't either. I'm just trying to get the shapes, you see. So there's like some lines, but then other places there's some unevenness, but other places they're a little square. So this creates a lot of variation here, you see. And also because I'm using the full grayscale range. When I paint the vertex colors, I get a lot of variations. I think a common mistake people make when making a height map mask is to make things too black or white, you know, too contrasty. You want to have a range in your texture, because this will give you different gradations, you know, like when you paint with the vertex colors. And by the way, I'm assuming that you know what a blend shader is, what vertex colors are. If you don't know what those are, these are probably not the tutorial for you, but you can learn. Just watch, and then you can find the information somewhere else that you don't have. So what else we have here? So there is the sharpness, which controls how sharp the transition is. So this is what it does. You can invert as well. Depending on the texture you're making, you can get some kind of cool effects. But for plaster, I just like to have it pretty sharp. And the next one inverts the mask. So this is only inverting the mask, not the transition. And the next one inverts the vertex color order. So this just flips what's green, what's black, what's white. And I'm gonna show how to do all of this. The next is the overlay. So the overlay is just a texture, like this one, that tiles horizontally in this case. And I have some top grime, some bottom grime, and like once again, I go deep in the environment art mastery how to create overlay textures, so I'm just gonna skim through it here. And so this texture gets overlaid on top, and I added a few options here. So the first one being enable overlay, and the second one, it uses the overlay on both layers. So if this is off, the overlay is gonna be only on layer 1. If it's on, it's gonna affect both layers. And I have a contrast here, and I tend not to use this too much because it breaks the, you see, it looks very artificial. So in Unreal, this contrast works a little better, I think. This contrast node works a little weird in Unity. And the other is just opacity, like how much overlay you get. And this is not working as it should because it shouldn't be red here. So I'm gonna take a look at this later. And UVs, and here is if I want to use UV2 or just the UV1. And this is so you can map the overlay to the geometry. Because if you're using tiling textures on the layer 1 and you put the overlay, that's how it's gonna look, right? Because the texture is tiling. But if you create a second UV channel and then you map the wall, you can use the UV2. And so yeah, that's how the shader works. So let's jump into the actual production. Okay, so let's get started here. And just once more, this is pretty much the same in Unreal. So if you're following Unreal, you should be able to get the exact same effect. And in fact, if you don't know, this environment was made in Unreal and then it converted to Unity. There's another video in the channel that you can watch to see how the conversion went. So this really proves that if you know how to make art, you know how to make art. It doesn't matter the tool. So okay, the first thing that we'll do here is create the HeightLERP function. And I love to work with functions because they allow you to simplify the shader code. So here's an overview of the architecture shader. Like it's pretty simple actually, right? There was a lot of functions, but it's pretty readable. You know, the sections are broken up in chunks, and I'm gonna go over each section and say what they're gonna and explain what they're doing. And the reason to use the material functions is that you can do this. So you see here, HeightLERP, that's my function. So instead of having this code, here I have just a node, and then you can make it modular. If you design your shader in a way that you're making good use of these nodes, the subgraphs, how they're called, you can make things modularly. You know, you can change the order. If I wanted to put the blend after the overlay or whatever, right, it wouldn't be so hard to do that. So to create one is very easy. So right click, create, Shadergraph, subgraph, and it works just like the normal, like a shader graph, but with less options, right? So here we can add an input. So for example, if you need, let's do like a multiply. So you take a texture and a vector 3. So this will be your color, for example, and multiply or contrast. Let's do like this. So we drop color, we drop contrast, and let's look for contrast, and then color goes here, and then out. That's it. So you have a output here, and you can create them here on the right side. So you see, like you can come here and let's put this like contrast result. But then you can add others here, right? This is a best way to make our code modular, because now you can come here and you can just drag and drop. So if you plug in the color here and the contrast float, you get the result. So that's how you use this. So again, this code for the HeightLERP I took from Unreal, and I don't understand 100% exactly what it's doing, but I know it works. So the gist of it is there's a LERP, and the LERP takes the input A and the input B and blends using the transition mask. And so let's start here. So start by creating a LERP node, put an input A and B. And by the way, let's create the parameters before we create this, because we are gonna need an input A and B. Those are vector 3. You can create those by going here. You're gonna need a contrast. This is a float. The transition is also a float. This is the sharpness. And the height texture is also a float. So here's where things get a little might get a little confusing, right? Because you're passing a texture, but why is it a float? Because it's a grayscale texture. You're passing the grayscale values. So the code doesn't care if it's if these values come from a texture or from a procedural mask or whatever. And then we add 2 booleans for invert the mask and the other one to invert the vertex color order. So these are the ingredients we're gonna use to make this HeightLERP. So start with the LERP, input A and B, just drag and drop like this, and plug this into the result, and the result is a vector 3. And so here, let's start from the beginning. We'll start with, so this is the code for the transition. So all of this will handle the transition. So let's move this like this. So the height texture is that float, right? We take that height texture, and here I added the first boolean, because if I want to flip this texture, I just need to run it through a 1- node. Otherwise, just use the original texture. So here we invert. And in Unreal, this is called a static switch, if I remember correctly. But it's the same. You put a condition, and then if this is clicked, it means true. If it's not clicked, it means false. So if this boolean here is clicked, the result will come from the 1 minus, which is 1 minus just means multiply by -1, inverts. Otherwise, height texture. And then we subtract by 1. So just add a subtract node and put 1. And then add node, and on the B you add the transition. This is the sharpness, again this is the sharpness. Multiply by 2 and then combine these two. Actually, I made a mistake here. The transition is not the sharpness, the transition is the vertex color mask. And this will come from the vertex colors node. Sorry about the confusion. So this is the gradient. This is what you want to use to actually blend this. And then we do a contrast. So now we do the contrast. This handles the sharpness. So this is basically combining the height texture we have with the vertex color gradient. I hope that's making sense. It's a little hard to explain how these things come, you know. And okay, so we do a contrast, and after this we do a clamp. So just add a clamp node and put 0 and 1. And the clamp, you're clamping those values to be mapped between 0 and 1, because if you don't do this, the values are gonna go much higher, and things will be like overly contrasty, overly bright, you know, like they're gonna go outside the range that we're looking for here. So this brings them back to 0 to 1. And one last branch here is to invert the vertex color order, which is just going to invert this whole thing here. So that's what it does. And that's it. So we plug this into the mask, into the transition for the LERP. And our HeightLERP node will be done. Now we go to the main shader here. And I think it pays off to plan ahead a little bit and create the parameters first. So whatever features you're gonna need, you can block out the shader first here by making the parameters. And to create these groups, all you have to do is just create a category here. And now you can add, you know, like whatever, like for example, use overlay. We can add texture, because I know I'm gonna need like color map. And you know, whatever information you need here, that's now is the time to add that. So for me, I have the layer 1 with tint, color, normal, ORM, and roughness multiply, and you can see here what they are. You can pause the video, you know, if you're recreating this, you can pause the video and look at the parameters. Let's open this. So I hope this is readable on the video. And yeah, those are all the parameters that I showed in the introduction of the video. Alright, so let's get rid of this so it's easier to see what's happening. And so let's go by parts here. And the first thing, let's create the layers, right? So the layer 1, pretty straightforward. You just drop the texture 2D and connect to a sample, texture sample node, and multiply by the tint. So this will allow us to tint this layer, the color. And here, default tangent space. And for the normal, we do the same, but then we change the type to normal. on the node. Make sure that every time you use a normal map, the type is set to normal here. The ORM, our packed texture, is the same, default, tangent, right? So the ORM comes with AO, roughness, and metallic. And I want to keep this packed, you know, like I don't want to unpack here, you know, like do like this and then do like this, do like this, because I want to keep it packed. So when I do the height blend, I blend the ORM only, you know, I don't have to blend the layers individually. So that's why that I split and then I multiplied the roughness. So here I added the roughness multiplier. You see, roughness multiply, and then I pack again, so you can use a split and combine. So this became the ORM map again. And for layer 2, exactly the same. You know, you just gotta use the other nodes. And if you notice, I named this with like normal 2 and normal 1, just so they had a unique identifiers. And yeah, so this one is the same with roughness and tint. So next, let's go to the overlay. So the overlay section, it's pretty simple. Here we have the overlay texture, which he is not gonna show here anyway. So it's just a normal texture, like a color texture, right? So we just drop to the texture sample. And here I'm doing the contrast, using the contrast node, but that's the one that I showed before that I was not very happy with. But basically, you want to have some way to do some adjustments to your texture, you know, like this is a cheap operation that allows you to have more variation out of less textures. So you can create material variants and just change this parameter to get a different looks. So that's why I like to do this, to add this kind of nodes here. And then we use the blend node. And this in Unreal is exactly the same. There is a blend node. But in Unreal, I think it's the different blends, they're separate. So there's gonna be one like blend overlay, blend multiply, and etc. And they work pretty much just like in Photoshop. And so here you can even have different blends, right? Depending on the shader that you're creating, like especially for effects. You know, you can do like a linear, like you can do dodge. You know, like if you want to have like a edge, like Fresnel kind of effect, right? So a lot of cool stuff here. But for this case, let's use overlay. And now it's very important the order that you do this. And it's a bit confusing because the overlay, you expect that it would be on the blend, but actually this goes on base and the base color. So here is our base color. And by the way, if you don't know how to add these knobs, you just double click. I think in Unreal you need to alt click. So always use this, you know, to make your code more readable. Like when you need to move stuff, you can kind of like straighten the edges, you know, like make things a bit more easy to follow. Like if you do like this, for example. So always make sure to untangle those lines as much as possible. You see, like, look how easy it is to follow here. So this is the base color. And the base color goes to blend. And I will show what it looks if we invert this. The colors are not gonna blend correct, you see. So the order here is important. If your overlay looks weird, just remember to invert the order here. And now we add those branches. So the first one is enable overlay, the layer 1. And if it's false, it's just gonna pass the base color. And then here, enable overlay. And we do it like this. And this, the reason that this is coming, like, so this, it looks like they're doing the same thing, right? And actually they are, because this is the main toggle for the overlay. And the way that I did here is I added the all layers as a separate overlay. So I think it would be easier to have the overlay after the blend, so I wouldn't have to have these two options. But I didn't want to remake the code, so that's why the overlay all layers is here in the end. And the all layers is basically blending the overlay texture that I showed before, like here, the overlay texture, with the result of the blend. So that's what it's doing. And the overlay UVs. So this is the code to choose if the UVs are going to be on the second UV channel or the layer or the first layer. And very simple code. So we start with a branch, right? And the branch is the use UV2 from overlay. And if it's true, we just add a UV node with UV2 here. In this case, it's actually UV3. Because UV1, I had lightmap UVs. That's a leftover from the time that I was using lightmap UVs on this environment. So I made all the overlays on my third UV. And so we branch. If it's false, you can just do like this. UV0. In my case, I'm plugging this from the UV scaling node that I'm gonna talk about in another video. So this node handles all the UV operations for all the layers, you see? Like it plugs into all the layers. And it just enables or disable the texture scaling with the object. So, oh, I didn't save this. And I use that for modular pieces, like here, for example. So like when I scale the piece, the UVs scale together. You see how the bricks are not getting stretched? But this is for another video now. So going back here, then we split, and the split here is so we can multiply. So this is just so I can have a way to scale the UVs. So you see I'm multiplying the R by the UV scale X parameter and the G by the UV scale Y parameter, and then I combine again and make sure that they're the R and G. When you use combine, you see like I'm using two values because it's UVs, right? Just X and Y. It's a 2D information. And then this plugs into the UV. And we're almost done here, actually. So now for the blend. And the blend, I put all the parameters here. So this is the reusable parameters, right? And this is what we're gonna feed into the HeightLERP node that we created. Remember, we need a contrast, transition, height texture. So we're gonna feed that. And so the sharpness, and again, if you're getting confused, this is just from here. Blend sharpness. This is just the parameter here, the float. And so this goes to sharpness. The channel mask is where this is for the transition. So what I'm doing here is I'm taking the vertex color input. So I created a node vertex color, and this is gonna have RGBA, right? And these are the colors that I painted in Maya. So I'm not gonna get into details of how to do vertex color painting here, But just know that I'm using the red channel to paint the transitions. And in Unreal, you can actually paint this in the editor. If you're not using Nanite, you can have per object in the editor, you can paint this. And if you're using Nanite, you need to disable Nanite, paint the vertex colors, save, and then enable Nanite again. But you can only have vertex color sets for like each object. They're gonna share the same vertex color set. And if you pay attention now, you will notice that this is just a transition, and this transition can be anything. In my case, I'm using vertex colors because it's easy to paint. It's easy to iterate. If I need to change this mesh, I can just repaint the vertex colors. But you can also bake this from a Substance Painter, for example. If you go the RGB mask, that's how you would do it. You would input that information instead of the vertex color. And if you're using Blender, it should be pretty straightforward. And it doesn't need to be the red channel, it can be the green channel, it can be the blue channel, but use only one channel because you want a grayscale value, 0 to 1. So put the vertex color node and then a channel mask, and here you can choose which channel you're using, so red channel, and this will go into the transition. The next one is the blend mask, the actual texture, right, that I showed before, the height mask. And then the two booleans, invert mask, invert color order. So now we add those HeightLERP nodes and just plug all those parameters. So contrast, transition, height texture, invert mask, invert color order. And here visually got a little confusing, but they all share like this entrance here. So if I want to change all of them later, I just have to change this entrance. So that's why it really pays off to break, you know, the nodes and create these knobs, because like here I can just plug this here, then it's gonna go to all of them. It creates a branch. And we are gonna need a blend for the color, for the normal, and for the ORM. And then after you plug this, the contrast, transition, all the parameters, all you have to do is just plug the input A and B, which is layer 1 and layer 2, right? So in the case of color, the input 1 is the result of the overlay operation here, which if this is disabled, that's why we do a branch here. Like if this is disabled, you see it's gonna take the base color. It's not even gonna run this code here if this is disabled. And the layer input B is the layer B, which is this one here. So that's the input B. And then you do the same for normal and ORM. And so now I added one more branch, and this is to enable or disable the blend. And if it's true, you see enable layer 2. If it's true, it's gonna take the result from the HeightLERP. If it's false, it's just gonna take the result from the overlay, which was the last one here, right? And then you can follow the logic here, because if this is false, you will take the overlay result, and then it goes back here, and oh, it gets here. Oh, is this false? Okay, so let's take the base color. So that's how you create these locks, you know, like you want to lock the parts of the code that you're not using if you turn off things. And this is a very important optimization. If you don't do this, and you have all these features turned on all the time, that's a lot of performance you're losing there for nothing. And then you repeat that for the other heights. And it's okay to, you know, to drop the same parameter multiple times. This is totally fine. And I think that's pretty much it. And in the end, the ORM, the result of the ORM, we need to split. and then the R goes to AO, ambient occlusion. The G goes to roughness, in this case here smoothness, and the M goes to metallic, not metallica, metallic. And okay, so I think that's pretty much it for this shader. I'm just gonna go over the entire code, so if I missed something, it's gonna be easy. You can just pause the video and copy. But I hope that this was understandable. It's a little hard to explain this, but I think it should be pretty clear. You should be able to figure this out. This is all basic stuff. Okay, so I'm just gonna go over the entire code, and I'll see you in the next video. I hope this was useful. Hey, if you enjoyed this video and you're looking to step up your environment art skills, I invite you to check my environment art creation course, Environment Art Mastery. This is a massive course that took me more than 2 years to put together and contains everything that I learned about environment art creation after more than a decade in the games industry. The course contains everything you need to know to be able to come up with your own ideas and take them to completion by using an easy-to-follow process that breaks down the creative process in logic steps. This process can be used to create all kinds of environments, no matter the style, theme, or engine. If you want to know more, visit environmentartmastery.com or watch the deep dive video in my channel. Thanks for watching, and I hope to see you again in the next video.